Hello class, welcome back. Today we're going to go ahead and continue section 7.3. Today we're going to be dealing with confidence intervals for mean when the sigma is not known. All right, some of you would refer to the introduction to the t-table test. All right, the t-table. All right, so let's go ahead and get started. All right, specifically for this section and moving on forward. All right, you're going to want to go ahead and use table F. Right, this table is also going to be provided in the D2L module page, so please print that out. Right, have it handy for your test. All right, if you purchase the physical copy of the book, you know that you may have, or you may find this table in the back. All right, so let's go ahead and get started. All right, so right, we need to find the t-value for alpha over 2, right, for the 90% confidence interval, right? And this test is going to be a little more simpler than the previous test, right? In the previous test, we were turning that percentage into a decimal, right? Subtracting things alpha over 2. Here's going to be pretty straightforward, all right? Here, for the most part, right? It's going to be pretty straightforward, all right? So whenever you pulled your t-table, right, you're going to look for the confidence interval that you're given, right? You got 90, 80, 90, 95, 98, and 99, all right? So similar to how you use the z-table, right? You cross your horizontal focus point with your vertical focus point, right? Similar to here, right? So I know I'm going to be using column 2, right? I'm going to be using column 2. The next thing where you need to know is how to find df, which is known as your degrees of freedom. Your degrees of freedom, it's always going to be your sample size minus 1. All right. All right. These are one of these formulas, right, that may not be on the formula sheet, but you're expected to know this. All right. All right. So here, right, my degrees of freedom for this problem would be h minus 1, which is 7. All right. So that means you're going to look for the column 90% and cross it with your degrees of freedom equaling 7, right? And you find out, all right, we find out that that value ends up being 1.895, meaning that my t-value for alpha over 2 is equal to 1.895, all right? As we progress with the class, right, you may ask to run, right, so for this part of the test, for the class, we're only going to be using this top column, right? As we continue, right, we're going to be introduced how to use this one and how to use this one. Right, but for the meantime, we don't need to look at that. Right, so the main thing here is degrees of freedom, right? Degrees of freedom. And your t-table should look like this, all right? T-table to look like that. And if you're solving the problems, right? If you're solving the problems, it'll give you the option to view it, right? To view it and download it, so you can save it to your desktop. All right. Let's go ahead and do problem number 2. All right. So overtime hours worked. A random sample of 13 registered nurses, right? Random sample of 13 registered nurses in a large hospital showed that they worked on average 43.8 hours a week, right? The standard deviation of the sample was 2.3. Estimate the mean of the population with 90% confidence, right? Assume that the variable is normally distributed, right? So one thing, let's go ahead and find out what's given, and specifically the formula we're going to be using in this section is very similar, right, to the previous section, with the exception that my s variable has been swapped, right? Well, we had a sigma there before, and instead of finding t alpha 2, right, we were finding z alpha over 2. So it still looks the same, right? It still looks the same. It just depends on what's been given to you, right? What type of question we're dealing with, all right? Here we're finding the mean of the population, right? So remember, that's a key word. So let's find x bar. Let's find t alpha over 2. We'll find my standard dev, and we'll find my n value, right? My x bar, it's my average, right? This here would be 43.8. My t value, that's what I need to find. My standard deviation, right, of the sample was 2.3. And my sample size, right, was 13. And while we're here, right, you may even want to find degrees of freedom while you're here, right? Where degrees of freedom is n minus 1, which is 13 minus 1, which is 12. All right, so let's go ahead and cross, right, for my t alpha over 2. I need to cross the 90% confidence interval. I need to cross that with my degrees of freedom, all right? Degrees of freedom, which ends up being 12, all right? So let's go ahead and find that on this table. All right, I have 90%, and I'm going to scroll down until I see 12, which is right here, right? Where was it at? Right here. All right, I've crossed that with the 90% confidence interval and my degrees of freedom. All right, so I get 1.782. All right. Okay, very, very nice. So at this point, I really have everything I need, right? I have everything I need to plug into the formula, right? Writing out the formula, right, is x bar minus t alpha over 2 times s over root n less than mu less than x bar plus t value over 2 s over root n, where the only thing that's different is this, all right? So I have here 3.8 minus 1.782 times 2.3 over root 13 less than mu less than 8 plus 1.82 2.3 over root 13. Woo, right? It's a handful. Let's go ahead and type that in. 43.8 minus 1.782 times 2.3 divided by root, was that 13? All right, I get here to 4 decimal places again, 42.6633 less than mu less than, I'm gonna switch that into a positive. All right, this ends up giving me 44.9367. All right, 1.9367. All right, so therefore here we see, right, that yeah, there we go. This here would be my solution, right? This here would be my solution. All right, meaning, right, if you were to explaining this, right, that I mean that one can't, one can be 90% confident that the true average hours worked between 42.7 and 44.9 hours are based on the sample of these 13 nurses, all right? Right, 42.6633 and the average of between 44.9367, right? So very, very nice. So it's pretty straightforward, right? Pretty straightforward. Right, but specifically, all right, what I mentioned in the last section, especially for the test, we're bringing it back. All right, we're bringing it back. All right, for your exam, you're going to be giving data just like this, and by hand, you're going to have to find the standard deviation, right, and everything else that's needed to solve the problem. All right, everything else that's needed to solve the problem. So let's go ahead and get started. All right, the digital camera prices. The prices in dollars for a particular model of digital camera with 6 megapixels and an optical 3x zoom lens are shown below for 3 online retailers. Estimate the true mean price for the particular model with 80% confidence. All right, so I already know, all right. Right, I got to do it for 80%. So here's nothing's given, and this is pretty much exactly what you can expect from the exam. All right, and you'll see in your homework, I'm gonna give you a lot of these, right? I'm gonna give you a lot of these, and it's for a reason. All right, so if you truly fully understand it, sure, right, you may want to do all of this in Excel, right? But I highly, highly, highly recommend you know how to do all of this by pen and paper, right? Because that's how is exactly what I'm going to require in the exam. You're not going to be allowed to use Excel, right? I'm going to give you these values, and you're going to have to remember how to find the mean, standard deviation, right, and all of that, right? It's already assumed we know how to find that, right? So there are a few values I need to find. right? And to find n, right? Let's write out what's given, right? Let's write out what we know. I don't know my average, right? I don't know my average yet. My t alpha over 2, I'll eventually find. My n value, right? That is just how many samples I have, right? Items in my sample: 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. While we're here, we may want to find degrees of freedom, which is n minus 1, right? Which is 8. And then my standard deviation. Man, I'm missing quite a lot of things, right? I'm missing quite a lot of things. All right. So what I recommend we do, right, when we're doing these by hand, is write everything out. All right, these are my x values. All right, these are my x values. This is going to be 194, 227, 31, 192, 249. Where to leave off? 245, 214, 201. All right. What am I doing? All right, what am I doing? I'm trying to find my variance, right? I'm gonna try to find my variance. Why do I want my variance? Because there's this very nice formula that states your variance, right, is equal to the sum of squares divided by your degrees of freedom. All right, meaning, in order for me to get variance, I need to find my sum of squares, right? And that's something we haven't seen since test 1, right? So the first thing I want to go ahead and do, right, to lead me to sum of squares, I need to have x minus x bar, where x bar is my average. All right, where x bar is my average. All right, so right, there we go. All right, so one thing I may want to find, right, is the sum of my x values, right? The sum of my x values, but is adding all these up together, right? Adding all of these up, we find out that this gives me 1942. Right, this here gives me 1942. All right, and we said you can find x bar, right, the average, by the sum of x divided by n. All right. So this here, right, would be x bar would be 1942 over, what was my n? 9. All right. Right, and we see here, right, let's go ahead and do what, 4 decimal, yeah, let's do 4 decimal places. Right, we see that my x bar, all right, it ends up being, let's go ahead and write it up here. It's 215.7778. That's my x bar, all right? Right, how we find x minus x bar, all right? That's going to be, and you know what? Let's go ahead and do what is asked from you in the homeworks. I believe it's just to 1 decimal place. I think that's what I have it set up as. That's 3 decimal places. All right. Okay, so we'll keep it like this. All right, we'll keep it like this. Make sure you have your calculator handy. All right. So what we're going to go ahead and do is x minus x bar. All right. Right. This here is going to be 194 minus 215.7778. All right. This is going to be 227 minus 215.7778, and so forth. All right. We're gonna fill all these values in. All right, you're going to fill all those values in. And I'm going to go ahead and fill these in to make sure we're all following along. So please, as I mentioned before, if at any time you want to go ahead and pause the video, please do so. All right. Please do so. All right, so dot 201 minus 215.7778. All right, man. All right. Let's go ahead and see what that gives me, 0.7778. All right. All right. Filling all these in, right, I get here negative 21.7778, 11.2222. All right, let's go ahead and see what else I can get here. All right. This third one, right, ends up giving me 15.2222. This next one gives me negative 23.7778. 26.7778. 33.2222. Ooh, we're almost done, I promise. All right, what do we got? 3 more. Very nice. This is 29.2222. Right, this is negative 1.7778. And last but not least, negative 14.7778. All right. What we do next, all right, is I'm going to square that difference, right? So meaning here is just going to be x minus x bar squared, meaning, right, you're just getting this, you're getting those values and just squaring them, right? So in other words, you shouldn't have any negative values, right, moving forward in this part. All these values here should be positive, right? So pretty much what you're doing here is negative 21.7778 squared. All right, 11.2222 squared. And in case you're wondering, why is it only positive? Because whenever you have a negative value raised to an even power, right, it always becomes positive. All right. I have here 15.2222 squared equals and so forth, right? That's exactly what I'm going to be finding. So let's go ahead and get these values plugged in. All right. All right, so whenever I do that, all right, whenever I square these values, squares, right? 474.2716, 125.9383, 231.7160. All right. 231.7160. Very nice. 565.3827. Let me go ahead and fill these in. All right, I get, I get 717.0494 equals 717.0, 1103.7160. Again, this 3, that's awesome. 853.9383. All right, I get 3 point, that's a small value, right? 3.1605. And the last one, I get 218.3827. All right. So it gave me, I squared those values, right? The cool thing is whenever you sum these up, the sum of those squared values, all right, this is also known as the sum of squares, right? SS, right? And whenever I sum up all those values, right, you'd find out that this gives me 4293.5556, all right? All right, that's exactly it. Whew, all right, so that's exactly what I was trying to find, the SS value. All right, so I have here, all right, so in order to find my variance, I know this is S squared is equal to the sum of squares over the degrees of freedom, meaning my variance is 4293.5556 divided by my degrees of freedom, right, which we know that's just n minus 1, which is 8, meaning my variance, right, is just going to be 536.6944. And if you were to square both sides of them, right, to take the square root of both sides of them, that gives you standard deviation, right? Meaning the standard deviation for my problem here would be 23.1667. All right. Wow. All right. Yes, definitely wow. Like I said, you are expected to know this for the exam. So please take your time with these. All right. Please take your time with these. That's going to be 23.1667. Right. At this point, let me go ahead and find my t, right? Let me go ahead and use the t table. All right. So we are dealing with degrees of freedom 8 and an 80% confidence, right? 80% and 8, right? 80% and 8. Right, is it 80%? Go ahead and check. Yes, so meaning, all right. Well, there we go. All right, we said 80% confidence interval, right? So I'm gonna go here and I'm looking for 8. All right, so that here, my t-value is going to be 1.397. All right, so meaning right? So it gives me all that. Gives me all that. I'm gonna go ahead and move this, right? Because I just need the space, all right? In case you want a full picture of a full image of what exactly was written, all right? I'm gonna go ahead and leave this up for a few seconds. You can pause the video, all right? All right, you may pause the video in case you need a zoom in version, all right? What was it that he wrote there? That, all right, so let's go ahead and you can pause the video. I'm gonna go ahead and now is take this here. Now I have everything that I need for this formula, right? I have everything that I need for this formula. So I have X bar, which is 215.7778 minus that t value, right, which is 1.397 times S, which is 23.1667 divided by root 9. Ooh, that's a nice number, right? It gives me 3. Less than, right? Very nice, right? So let's find out what this ends up giving me, all right? 215.7778 minus 1.397 times 23.1667 divided by root 9, right, which is 3. All right. This here ends up giving me, we'll go ahead and do 4 decimals. 204.9898 less than mu less than the same thing, but just switching that negative to positive. So this here gives me 226.5658. Woo, right? So one can be 80% confident that the true mean price, right? Oh, we're talking about price here, right? So right, we're talking about price 204.99 less than mu less than 226.57 cents. All right. So one can be 80% confident that the true mean price is between these two values, right? Based on the sample of n equals 9 for the problem given. All right. So, right, like I said, that is how you go about solving that information. All right. So let's just say, hey, I know how to do this by hand. I want to go ahead and use Excel. Yeah, you can go ahead and find Excel, right? You know the code for variance and standard deviation, right? If you're wondering, hey, how can I use this table? All right. How can I use the table that you made, right? But in Excel, all right? Very good question, right? So I'll say that this is X. I'll call this X minus X bar. And I'll call this X minus X bar squared, all right? And one thing I could probably do is I can find the variance, and the standard deviation by code, right? Just to be sure that what I'm doing is correct. And I would recommend you do that, right? I would recommend that that's something you may want to do. All right, that's something that you may want to do. So I'm going to write var, right, variance. I'm going to highlight all these values. All right, so that's my variance, meaning my standard dev, right? STDEV should be 23.1. Very nice, right? Yeah, it's right. The same values I found, right? The same values that we got. So one thing I would probably do is let me close that off. Let me close that off. So one thing you probably want to do first is go ahead and move this up a little bit. Let me find X bar. All right. Let me find sum of X. All right, which is just summing this column, right? So this would be sum. Highlight all of these. Right, 1942. My n, right? What was my n? Right, how many values I had there, right? And that was 9. All right, so this is 9. That's 9. All right, and we said we can find x bar. All right, x bar. All right, by getting the sum of x. So equals sum of x divided by 9. All right. And that's just my average, right? If you wanted to go ahead and use the code for average, right, equals average, and highlight these, sure, you can go ahead and do that, right? But I want us to know how to use it, right? Use it as manually as possible, right? But and again, you can also use average to make sure that your sum of x over n is the same thing as your x bar, right? So you have all these options, right, to make to find these corrections, right? So one thing I want to do here is do this x value minus the x bar, right? So I don't want you to put 194 minus 215.7778, right? It's an easier method. So you're gonna write equal. I'm focused on this minus this part in the bottom. All right. Minus that part in the bottom. But I'm going to want to do this for everything below it. And I always want x bar to always be this value. All right. So I'm going to put these dollar signs in the front of B and in the front of 13. That locks it. Right. That right there is going to lock that. Meaning that if you were to go ahead and get this and slide it down, right? Look at the code here. It's getting the next cell to the left, 227, right? Because I brought it down. I'm telling it, hey, as I'm bringing this down, I want you to, whatever's next to you, do the same thing that was being done above, right? But the exception here is if you lock it, even though you may be moving down, it's always going to lock that X bar to whatever value you highlighted, all right, with the dollar signs, right? Meaning you can go ahead and fill all of this down. Ooh-wee. Very nice. All right. Right. So if you look at the code, right, it's still using that, right? It's still using that, right? So you may ask yourself, hey, what if that dollar sign wasn't there, right? What if that dollar sign wasn't there? All right. So, right, what it's doing here, right? What it's doing here is, right? So it was 194 minus that X bar. Since you're highlighting everything down, you're telling every cell, copy everything to your left and bring it down, right? Copy everything that I highlighted and bring it down. Look at 227. Look at this. It's used the number, it used the cell below it, but it also used it for the X bar below it. But that's not what I want, right? And if you go to the third one, it did the same thing. Sure, it used the cell below it on my X values. But again, why is it, there's nothing there. I want it to be locked on that 215.777. 8, right? And that's the importance of having these dollar values, all right? Go ahead and move that, shift that down, right? Meaning it gets locked in no matter what, all right? So for this next part, right, you can do, right, for x minus x bar squared, it's going to be the other value squared. So, right, you have two options. You can do this squared, right, which is going to give you that 474, or you can do what's squared. It just means this times this itself. It's just two of those, right? Regardless what you choose, it's going to give us the same answer, right? So this here would be a squared. All right. So again, right, I want to copy that the same equation down all the way. So it's going to copy it down all the way. Right. It's going to go ahead and copy it down all the way. Let me go ahead and block this off. We said, right, that I can find the sum of this column, right? This was known as SS, all right? The sum of the squares column, all right? So all I'm going to do here is going to do equals sum. Let me sum all these values up. Ooh, what did I do? Ooh, no, escape, right? If you ever accidentally press something and it's not letting you exit out, right? It's stuck on that equation, press the escape button and it'll take you out of that. So my sum of squares is that, right? My degrees of freedom, right? It is n minus 1, which is 8, right? Meaning that formula, right? S squared, right? For my, right? What was that formula? Right? S squared, my variance is the sum of squares divided by the degrees of freedom, right? Meaning this here is going to be this value divided by that value. Okay, so this is my variance. And hey, look at, compare these two. The code that you put automatically, all right? It's the same thing, right? And how do you find S given that? Well, you take the square root of it, right? Take the square root of it. Woo, very nice, right? Very, very, very nice. So it gives you that, right? The benefit of doing things in Excel, right? Let's just say that these values changed, right? Let's just assume that these values changed. The beautiful thing about writing these equations is that if you notice, all these equations are based on this itself, these data values here themselves, right? So let's just say that I go ahead and do a different example, right? I go ahead and do a different example. You wanted to go ahead and try a different example on the homework, right? I'm still dealing with 9 values, right? I'm still dealing with 9 values, right? I have this example pulled up, right? But in those individual values change, so I know everything's going to change, all right? So meaning I now have 245, 214, 201, 221, 180, 200, 187, 265, and 222. Right. The great thing about that is that since this changed, this sum of x also changed. This x bar also changed because it's all dependent on that equation. It's all depending on that code. Therefore, meaning this x bar changed as well, and this changed as well, right? Right. So that's the cool thing about it, is that you can change one little thing, but everything is going to automatically be changed for you, right? So it's not like you have to recode everything, all right? It's not like you have to recode everything. Sure, if your n is different, if you have more n values or less n values, you're going to have to delete some stuff. But as long as your n values are fine, right? That's, it's totally cool, right? So yeah, very, very nice. This is exactly how you solve that, right? Using Excel. And like I said, all right, please be sure we understand how to solve this, because it is going to be required for test 3. And that is all I have for you all today. Thank you very much for your time, and I hope you enjoy the rest of your day. Thank you.